Hello everyone, this is Mr. Millen. I'm here with an instructional video on surface area and volume of composite 3D figures. So in this lesson, we're going to talk and kind of combine the different types of surface area and volume we found during the previous lessons with all the other 3D shape and work on combining those into composite 3D figures. So a composite three-dimensional object is defined as an object made up of multiple three-dimensional objects. This is done by joining either the faces or bases of an object together. So you may have 2, 3, 4, any number above 2 or 2 or more would be acceptable for a composite object. So common composite three-dimensional objects include objects made from cones and cylinders, hemispheres and cylinders and cones, pyramids and prisms. And the thing about a hemisphere is, if you've paid attention in science, you talk about the Earth and other planets and how they have different hemispheres. So you have something like the northern and southern hemisphere. And you also have the western and eastern hemispheres. So a hemisphere is simply half a sphere. Okay, so it's exactly half a sphere. So how are we going to determine the surface area and volume of composite 3D objects? Well, to determine the volume, the first thing that we're going to have to do is identify the three-dimensional objects that are used in the figure. So that's always important because that's going to let us determine what formulas we need to use to determine the volumes. The next is going to be to find the volume of each 3D object that is used in the figure. So if you have 2 3D objects in the figure, then you're going to find 2 different volumes. If you have 3, you're going to find 3, and so on and so forth. Then you're going to, after you find the volume of each one, you're going to find the sum of the volumes of the other three-dimensional objects used in the composite object. So if you have a cylinder and a cone, you would take the volume of the cylinder and add it to the volume of the cone, and that would give you the volume of the composite 3D object. Now, surface area can be a little bit more complicated. We still start off identifying the 3D objects that are used. But here, in our second step, we're going to be finding the lateral area of the 3D objects that are used in the figure. Now, as far as that goes, though, not all shapes have a lateral area. For instance, a sphere does not have a lateral area. So you would simply use the surface area formula for that one. And if it's a hemisphere, you would have to cut it in half. Then after you find the lateral area or surface area, you find the sum of the areas of the 3D objects used, and that will be your answer. Okay? So let's look and see how that works. The first one that we're going to be looking at here is this figure, and it kind of looks like a snow cone. So what 3D objects do you see in this picture? Well, here you clearly see that there is a cone here, and you should see at the top bit here that we have a spherical object, but it's not the entire sphere. We have a hemisphere. So I'm going to label these in different colors. So when I do this, it's a little bit easier to differentiate here. So find the surface area and volume. We'll start with the surface area. So the surface area of the entire figure, we're going to have to find the surface area of the hemisphere as well as the cone. So with a hemisphere, we first have to find the surface area of the entire sphere because we don't have a specific formula for a hemisphere. So for the hemisphere, our surface area is 4 pi r squared for the whole sphere. So in this case, r is 5, our radius is 5. So 4 pi times 5 squared. 5 squared is 25. 25 times 4 is 100. And then tack on the pi. But that's the surface area of the entire sphere. So to get the hemisphere, we have to divide this by 2, which gives us 50 pi. All right, next up, we're going to do the cone. And so the cone, the surface area of a cone is not relevant here. And the reason it's not relevant is because we're only looking for the curved surface here, the lateral area. So the lateral area is defined as pi RL. So you get pi, R is 5, L is 13. 5 times 13 is 65. 65 times pi is just 65 pi. We're not finished yet, because after we found the surface area of those other objects, we need to add those together in order to get our full surface area. So the surface area of the entire figure is 50 pi plus 65 pi, which, let me make sure of this. I have my key here, so give me just a moment. So 65 pi plus 115 pi would give, or plus 65 pi would give you 115 pi, which is approximately 361.28. And what are our units? We're doing surface area, so it would be centimeters squared. Okay. All right, so now let's look at the volume. So we're going to look for the volume now. So again, we have to determine the volume of the hemisphere and the volume of the cone. So we'll start out with the hemisphere. So to determine the volume of a hemisphere, we first have to find the volume of the whole sphere. And we do that by using the formula 4/3 pi r cubed. And so we get 4/3 pi, and then r is 5 cubed. 5 cubed is 125. 125 times 4 is 500 over 3 pi. Now, if you ran that through Desmos or whatever else, then you could simplify it to get 500 over 3. Then that's your whole sphere's volume, so you need to divide that by 2, and you get that your hemisphere's volume is 250 over 3 pi. Now we need to do our cone. So for the cone, the volume is defined as 1/3 pi r squared h. So you get 1/3 pi. The radius of the cone is 5. The height of the cone is 12. 5 squared is 25. 1/3 of 12 is 4. 25 times 4 is 100 pi. Okay. Then to figure out the volume, you add the two volumes together. So your total volume is 250 over 3 pi plus 100 pi. And if you round that out to the nearest hundredth, you get 575.96 centimeters. And since we're doing volume, we need to have cubed on the end of our volume. So we need cubic centimeters. Now, I will say that in some cases, you won't be given one of these things if you have like a cone, but notice here that the height forms a right angle with the radius, and that makes your slant length be your hypotenuse of the right triangle. So you can use the Pythagorean theorem, a squared plus b squared equals c squared, to determine the missing value. You may need to do that for some of these problems in the future. So let's look at number 2. Number 2 says to find the surface area of the figure below. So we're just looking for the surface area. And in this figure, what shapes do you see? Well, you see a cylinder here in the middle. You see a cone on the left and a cone on the right. Are those cones equal to one another? And you should see that no, they're not equal to one another, because one of them has a slant length of 3 and the other has a slant length of 4. So we're going to have to do 2 different cones because they have 2 different measurements. So we're trying to find the surface area. So we need to find the lateral areas, if possible, of the cones and cylinder. So we're going to look at the cylinder first. So your surface area, your cylinder, the surface area for the lateral area, excuse me, because we have to do lateral because it's a composite. The lateral area is equal to 2 pi r h. So for our cylinder, what's our radius? Well, our radius is 2. You see that there. And what is the height of the cylinder? Well, if we were to stand this up to where the circles are on the bottom, 6 would be your height. So the 6 is your height for your cylinder. 2 times 2 is 4. 4 times 6 is 24. So you get 24 pi for your lateral area for the cylinder. All right, now we're going to do the first cone. So for a cone, the lateral area is defined as pi RL. So what is the radius of this first cone? Well, the cylinder, both of these circles are identical. That means they have the exact same radius. So this circle had a radius of 2, so this circle must also have a radius of 2. So the radius of this cone is equal to 2, and the slant length is equal to 3. So we get 2 times 3, which is 6, and then the pi drops down. And now we need to do our final object, which is the second cone. So the lateral area again is pi RL. So we have pi, R is 2, and L is 4. So 2 times 4 is 8. The pi drops down. We have our 3 lateral areas. So now to figure out our surface area, we just add those together. So 24 pi plus 6 pi plus 8 pi gives us 38 pi, which is approximately, let me make sure, which is approximately 119.38 meters squared. And again, we have to use squared because we're doing surface area, and surface area is always measured in squared units. All right, so let's look at number 3. Number 3 says to find the volume of the figure below. So what shapes do you see there? Well, the bottom is very clear. The bottom is a rectangular prism. Okay, so the bottom's very easy to see. I'm just going to call it RP for rectangular prism. But the top, what does the top look like? Well, the top sort of looks like a cylinder, right? However, the cylinder here is cut in half. So we're going to have to take that into account when we do this. But let's start with our volume. We're going to start with the rectangular prism first. So the volume of a rectangular prism is given to us by length times width times height. So the length of the rectangular prism is 16. The width is 9, and the height is 5. If we take 16 times 9 times 5, that ends up giving us 720. All right. Now let's look at the cylinder. Now again, this cylinder is half a cylinder. So when we find the volume that the whole cylinder would be, we need to make sure we cut it in half. So the volume of a regular cylinder is given to us by pi r squared h. What is the radius of that cylinder? Well, we see from here to the diameter would be 8. So our radius is 8. And what is the height of the cylinder? Well, the cylinder normally sits on the circular bases. So if you tilted this upwards, this line here would be the one that's standing straight up. So this line's length would be your height. Well, this line is part of the rectangular prism, so it would be equal to 9 because those two have to be congruent. So if you take 8 squared times 9, you get 576, and then the pi drops down. But that would be the volume of the entire cylinder. We don't have a volume for the entire cylinder. We only have half of it. So our volume would be 288 pi for the half cylinder. Now to find our volume, we just add these together. So you get 720 plus 288 pi. And if you approximate that to the nearest hundredth, you get 1624.78. And then since you're doing volume, it has to be cubic units, so feet cubed. Okay, number 4. Number 4 wants us to find the volume of the following figure. So what shapes do you see in this figure? Well, at the bottom, you should see a rectangular prism again. And at the top, you see a triangular prism. Now, this is not a triangular pyramid because it has 2 different triangular faces, which means that these are the bases of the triangular prism. That's why it's called a triangular prism, because the bases of it are triangles, okay? And the rest are connected by the rectangles. So let's start with the volume of our rectangular prism. So our volume is given to us by length times width times height. The length is 25, the width is 22, and the height is 9. So 25 times 22 times 9 would give us 4,950 inches cubed. That's for our rectangular prism. Now we need to do the volume of the triangular prism. So for the triangular prism, your volume is given to you by the base area, big B, times the height of the prism. Well, in order to find our base area, we have to know what shape our base is in. Well, since this is a triangular prism, the base is in the shape of a triangle. So big B, you're going to have to use the base of the triangle and the height of the triangle. So the area of a triangle is given to you by 1/2 times the base of the triangle times the height of the triangle. Well, what is the base of the triangle? Well, you should see that the base of the triangle is equal to 25 because it's this line here, which would have to be congruent to this one. So we know we have 1/2 times 25. And what is the height of the triangle? Well, that would be this line here. So from this point to this point, what is that height? Well, you see here we have a 24-inch total height from the top of the triangular prism to the bottom of the rectangular prism. Well, we also know that the height of the rectangular prism is equal to 9. So if you want to determine what that height is, you have to subtract the total height and the rectangular prism's height to get it. And that would be 15. So 1/2 times 25 times 15. And if you multiply all of that together, you get that big B would be equal to 187.5. So we can plug that in here. Now this H is not the height of the triangle. It's the height of the triangular prism. Okay, so if you were to put this on the base, which would be the triangle, you turn this over, this side right here would be sticking straight up. This side right here would be. Well, the thing about that is that that side is congruent to this side. So we know that the height of the triangular prism must be 22. Now we just multiply those together and we get the volume would be 4,125. We have both of the volumes we need, so we just add those together, 4,950 plus 4,125. And when you do that, you end up getting 9,075. And then your units would be inches cubed because we're doing volume. All right, number 5. Number 5 says to find the surface area of the figure below. And what objects do you see in this figure? Well, the first one we see is another rectangular prism. And you also see that we have a pyramid. We have a pyramid. We know this one's a pyramid because it only has one base and the other faces meet at this point. So we have a pyramid here as well. So I'm actually going to determine the surface area of the pyramid first. Because this base is conjoined with a rectangular prism, we're using the lateral area. So for the pyramid, your lateral area is going to be equal to 1/2 times your slant length times the perimeter of the base. So in this case, what is your slant length? Well, you should see here there's a dotted line starting from the apex going downward, and that would be equal to 5. So your slant length L is equal to 5. And how do we normally determine the perimeter of an object? Well, the perimeter of an object is all of the sides of that object added together. So we have to determine the perimeter of the base. So what shape is that base in? Well, we can see from our measurements that this would be 3 and this would be 3, so the base is in the shape of a square. So for the perimeter of a square, we would add 3 4 times, or we just multiply 3 by 4. So that would give us a perimeter equal to 12. Then we just multiply 1/2, 5, and 12 together, and that ends up giving us 30 for our lateral area of the pyramid. All right, now the rectangular prism. And this is where it gets a little bit tricky because you have to kind of pay attention to these things. The surface area of this rectangular prism, you normally have how many faces uncovered when you have a rectangular prism? You normally have 6, but in this case, you have the pyramid which is joined straight on to this square. So if you are trying to determine the surface area of this part of the compound object, the rectangular prism, you can't just use the whole surface area. You can use 5 of the faces, but not this one. So when we find our surface area, we need to subtract the area of this square from our surface area. And I'll show you how we're going to do that. So the rectangular prism, the surface area is given to us by 2 length times width plus 2 length times height plus 2 width times height. So our length is equal to 8. Our width is 3. Again, our length is 8. Our height is 3. And then we just plug in 3 for both the width and the height. If you were to add all of that together, you would end up with your surface area being equal to 114. However, that's for all 6 of the faces showing. We have one that is not showing. So we have to get rid of the area of a square. So subtract the area of the square. So how do we determine the area of a square? Well, this side is 3, this side is 3. We multiply those together. So we take 114 and subtract 3 times 3. And we get 114 minus 9, which is 105. Well, our pyramid and our rectangular prism, when put together, would be 30 plus 105, which is equal to 135 feet squared. Okay, and our last one here that we are going to go over in this video, just because it's a little bit unique. We want to find the surface area and volume of the figure below. I'm going to find the volume first, and I'll explain that because we already have the height, radius, and height of the cylinder. We do not have the slant length yet for the surface area, and I'll show you how we're going to find that in just a second. So our surface area, or our volume, excuse me, we have a cone and we have a cylinder. Okay, so a cone and a cylinder. Well, for the cone, the volume of the cone is given to us by 1/3 pi r squared h. So in this case, r is equal to 2, and the height of our cone is equal to 6. 2 squared is 4. 4 times 6 is 24. 24 times 1/3 is 8. So the volume of the cone is equal to 8 pi. Now we do the volume of our cylinder. The volume is equal to pi r squared h. So the radius of the cylinder is equal to 2. The height of the cylinder is equal to 14. 2 squared is 4. 4 times 14 is equal to 56. We have our 2 volumes. We just add these together to get the volume of the entire thing. So you get 8 pi plus 56 pi, which is equal to 64 pi. And 64 pi be approximately 200.96 meters cubed. All right, now we're going to look at our surface area. Now for the surface area, we're going to do the cone first, but for the lateral area of a cone, you need to know that the lateral area is pi RL. So pi RL, we know the radius is 2, but what is the slant length? Well, the slant length would be here, and we don't know that. However, we do know that these two, the height and the radius, form a right triangle, with the hypotenuse being the slant length. So we can use a squared plus b squared equals c squared. So a is 2, so 2 squared. B is 6. 6 squared is equal to c squared, which would be L squared. 2 squared is 4. 6 squared is 36. 4 plus 36 is equal to 40. We need to get rid of that squared, so square root both sides. And we get that the square root of 40 is equal to L. Now we just plug that in. So square root of 40. And we get that the cone has a lateral area equal to the square root of 40 times 2 times 3.14, which is approximately 39.72. Now we need to find the surface area of the cone. And just like this one up here where we had a face exposed, we're going to be doing the exact same thing here. However, we can find the lateral area and then just add on the circle part to it. So for the cylinder, our lateral area is normally pi r, or 2 pi RH. However, that only deals with the curved surface. We also need to add one of the circles on, and the area of a circle is given by pi r squared. So plugging in, we get 2 pi times r, which is 2, times the height, which is 14, plus pi times r squared, which would be 2 squared. 2 times 2 is 4. 4 times 14 is 56. 2 squared is 4. 56 pi plus 4 pi gives us 60 pi. Now to find the actual surface area of the whole object, we take 39.72 and add 60 pi. And if we do that, we get that our surface area is approximately 228.12 meters squared. And that's going to do it for this video, guys. I hope this video has helped not only in explaining the compound 3D objects found in the surface area and volume, but giving you a bit of insight and practice into using each of the formulas appropriately in order to determine these surface areas and volumes. So make sure you work on the assignment, and I will see you in the next video.